Okay, so for day 2, we're going to look at 2 more properties. The first one is the quotient of a power's property. And we start off again with the question, what does a to the 5th over a squared mean? So if I was to write that out, a to the 5th we know from yesterday means a times a times a times a times a, all over a times a. And just like in fractions, when you have the same number over the same number, I can cancel an a from the numerator and denominator, and a from the numerator and denominator, and all I'm left with is a to the 3rd power over 1. Let's take a look at another example. And that would be a to the 5th, b to the 7th, all over a squared b to the 3rd. And again, if we write this out, it would be a 5 times, and b a total of 7 times, 2, 3, 4, 5, 6, 7, just like we did the other day. An a in the denominator and a b in the denominator. And again, we cancel out anything that's the same. And so we're left with a 1 in the denominator, and in the numerator I have a to the 3rd, b to the 4th. Well, I'm wondering if there's a shortcut for us rather than having to write it out. And what I'm noticing is I had an a to the 5th and an a squared. And if I would have done 5 minus 2, I would have gotten to my a to the 3rd power. With the b's, I had a b to the 7th and a b to the 3rd. And again, if I simply would have subtracted 7 minus 3, it would have gotten me to b to the 4th power. So what we have here is the quotient of powers property, which says if a is a non-zero number and m and n are positive integers, if we want to divide powers with the same base, all we have to do is subtract the exponents. So in this example, 4 to the 7th divided by 4 to the 2nd, same bases, all I have to do is do 7 minus 2 to get 4 to the 5th power. You have 4 examples below. Take a moment, put the video on pause, and see if you can try those 4 examples. Here's a quick snapshot now of the answers to those 4 examples. Check your work. Put the video again on pause if you need to take a moment to look at it. The second property that we're going to look at is the power of a quotient property. And the question is, what does a over b, this quotient, all raised to the 3rd power, really mean? And it means that everything inside, both the numerator and the denominator, are raised to the 3rd power. So it would be a over b times a over b times a over b. That's what it means, which would simplify to a to the 3rd power, b to the 3rd power. The shortcut for doing this is simply to think about a to the 1st power, and I'm really multiplying 1 times 3, which gets me to a to the 3rd power. b was also to the 1st power, and when I raise it to the 3rd power, all I'm doing is multiplying 1 times 3. So the power of a quotient property says to find a power of a quotient, find the power of the numerator and the power of the denominator. And then it says to divide if necessary. So if we would go back to this second example, 2x all over 5 squared, what we're really doing is we're saying to ourselves, okay, it's 2 to the 1st, x to the 1st, and 5 to the 1st. And I'm going to multiply the powers. So 1 times 2 would give me 2 to the 2nd. The x is raised to the 1st and then raised to the 2nd. 1 times 2 gives me to the 2nd power. And the 5, which is raised to the 1st power, is going to be raised to the 2nd, so that becomes 5 squared. With any numbers, if you can, you should evaluate them. 2 squared is 4, and 5 squared is 25. So again, below the power of a quotient property, you have 2 examples. Put the video on pause, see if you can try them, and then we'll come back in a moment to check them. Now that you've had a chance to try them, here are the final answers that you should have for each one. If you need to, you can put the video on pause so you can check them out for a moment. And on the following pages, you have pages 1 of homework and page 2 of homework. Please try those for tonight's examples. Thank you.